Hello students, today we are going to study about the chemical properties of alkanes and the conformation of alkanes. Okay, so starting with the chemical properties of alkanes. Okay, different types of chemical properties, different types of reactions this alkane shows, like substitution reaction, nitration reaction, sulfonation reaction, oxidation reaction, aromatization reaction, okay, and so on. So first, coming to the substitution reaction, what do we mean by substitution reaction? It means some replacement is being taking place, isn't it? Something is being substituted. Okay, so in this, first let us study about this in substitution reaction, the halogenation reaction. Okay, how does this halogenation reaction occur, or how it is initiated? Reaction takes over with the help of what? The sunlight, or by heating, or by the ultraviolet radiations. Okay, so when we are talking about the halogenation reaction, it means the halogens will be coming over here as a reacting agent, isn't it? So here we'll be saying that what are the halogens actually? Fluorine, chlorine, bromine and iodine. And if we say about the order of the reactivity, or how vigorous the reaction will be with the all the types of halogens, okay, we can see that yes, for fluorine will react very vigorously, then chlorine, then bromine, then iodine. Okay, in this manner the halogenation reaction will take place and reactivity will be in that manner. Okay, so the least slow, very slow reaction will go with what? Iodine. Okay, now when we talk about the replacement of this hydrogen, so how, which will be showing the tertiary, the secondary or the primary? The tertiary, okay, here we'll be seeing the reaction too fast, then the second degree or the secondary, and then the primary. Okay, in this manner the replacement of hydrogen will be there. Okay, so now come first, we'll be seeing with the example of chlorination, the reaction mechanism, how this substitution reaction is taking place. Okay, so first of all we have chlorine. Okay, so chlorine, here first this Cl2 in the presence of the ultraviolet rays, okay, what will happen? It will break. Okay, it will break. And here homolysis is taking place. Why homolysis is taking place? Because this electron is equally distributed with the two chlorine, and this chlorine with one electron over here we are seeing, which is reactive in nature. Okay, it is acting as what? A free radical. This chlorine also and this chlorine also, both the chlorine is acting as a free radical. Now it is in the active state. Okay, so now how the reaction will propagate, how the reaction will go on. Okay, let us see how what happens. See, when an alkane, we have taken over here this methane, okay, CH4, okay, see here one hydrogen will be replaced by this free radical of chlorine, okay, and thereby making what? Here CH3, here also. Now one electron is free, which is very reactive in nature, and HCl will be formed. Now this CH3, okay, consisting of one active electron, okay, what will happen? It will again react with Cl2, okay, thereby forming what? CH3Cl, methyl chloride, and again this chlorine free radical is generated. Okay, and this free radical now reacts with this CHCl3, okay, thereby making HCl. Here it is stable, but now the one hydrogen has been replaced, thereby making it what? CH2Cl. Okay, now this CH2Cl is now active in nature, reacting with chlorine, okay, molecule, forming CH2Cl2, and again chlorine free radical is generated. Okay, and then this again acts with CH2Cl2, okay, replacing this one hydrogen, thereby forming CHCl2, okay, having a free electron over here, okay, and here HCl is stable. This is how the reaction is going on. Unless and until a free radical is generated, the reaction will not propagate. So you should keep in mind that yes, the reaction will go on unless and until it becomes stable. Okay, so here now CHCl2, okay, reacts with Cl2, okay, and forming what? CHCl3, that is what? Chloroform, and one free radical of chlorine is again generated. okay, and this again reacts with this chloroform, thereby forming a stable product, that is HCl. But here CCl3, it is not stable. Here one electron is free, okay, thereby initiating it to go on with the reaction, okay. Again CCl3 reacts with Cl2, forming CCl4, and yes, a chlorine free radical. Here, so from the beginning to the end, we have seen that all the hydrogen atoms which were present in methane has been replaced now by what? Chlorine. Okay, so this type of reaction, okay, here whole H will be replaced, one by one it is replaced, and in this manner the reaction is propagating. But yes, the reaction should stop also, isn't it? So how will this reaction terminate? When it will be terminating? Where we are seeing here chlorine free radical is being generated. When this free radical of chlorine reacts with another free radical of chlorine, thereby forming what? CCl2. This is now a stable product. Naturally the reaction will now stop. Okay, now here also you can see this methyl and this methyl both will react to form what? Ethane. Now this reaction can terminate. Okay, now if CH3 and a free radical both react, chlorine free radical both reacts to form what? CH3Cl, that is methyl chloride, and then also the reaction will stop. So these three ways can terminate this reaction. Okay, when we have studied right now here for chlorination. Okay, if we are taking bromine, it will be bromination. Okay, that reaction will also propagate in this manner only, but the reaction will be slow from chlorination. Okay, and when we come to iodination, okay, here what happens, this reaction is very slow, very slow, and it is a reversible reaction. Okay, so in order to carry out the reaction fastly, we carry out with using some oxidizing agents, like you can see here HiO3 or HNO3. Okay, here if we use these two agents, naturally the reaction will go fast, and you will be seeing that yes, the reaction is taking over. And yes, if the oxidizing agent is not added, so what will happen? The reaction will not go fast. Okay, so here we are seeing that yes, the reaction is going on. Yes, we have added here HNO3, suppose the oxidizing agent. Okay, it will react with hydrogen iodide to form what? Iodine and water. Okay. So we have studied about chlorination, bromination and iodination, okay, how it is taking over. Okay, when we talk about this fluorination, okay, the reaction is very fast, okay, and very vigorous. Here carbon-carbon as well as carbon-hydrogen bonds both breaks, okay, and here we will be seeing a mixture of products will be formed. Okay, so this should be avoided. So in order to avoid that, okay, what happens in this, along with fluorine, some inert gases are added, okay, so that the reaction can proceed, and yes, the substitution reaction can take place. Okay, and yes, fluorination reaction is also carried out by using what? Some chlorides, okay, methyl chlorides, ethyl chlorides, okay, and we can get that. Like if we are taking CH3, CH2 and Cl, plus we are adding Hg2, Cl2, okay, Cl2 now, F2, okay, so we will be getting what? CH3, CH2, and here we'll be getting F, plus we will be getting what? Hg2, Cl2, okay, balance just the equation, balance it, and here this is how fluorination reaction can take place. Otherwise what will happen? There will be a mixture of products formed which will be a complex one. Okay, so substitution reaction is proceeded for fluorine in this manner, either with the inert gas, adding of inert gas, or by using what? This chlorides, okay, alkyl chlorides, and we are using fluorine in this manner, then only we can get the reaction of substitution reaction. So now coming to the nitration reaction, okay, here we will be seeing this hydrogen atoms will be replaced by nitro group. Okay, so we have taken a normal alkane, okay, and here this alkane is what? Propane, isn't it? This is what? Propane. Okay. So here we have added what? HNO3. Okay. And temperature should be maintained. Okay. 670 Kelvin, or you can write 670 to 680 Kelvin. Okay. But don't write too more or too less temperature. Okay. So here taking this alkane, that is propane, adding what to it? HNO3, taking a specific temperature 670 Kelvin. Okay. Here we can see that here one hydrogen has been replaced, isn't it? By which? The nitro group. Here also you can see one hydrogen has been replaced by the nitro group. Okay. See, here we are getting 2, but here in this one will be getting 80% and this one will be getting in 20%. Okay. But both of them we will be getting. This is what? Nitropropane, and this is also nitropropane, one in 80%, one in 20%. Here we are seeing this hydrogen has been replaced, there also hydrogen has been replaced, thus it is a substitution reaction. Okay. Now, sulfonation reaction. What happens in this sulfonation? It means what here? Here hydrogen atom will be replaced by sulfonic acid. Okay, and here order of reactivity will be seeing the tertiary more and then the secondary and then the primary. Okay. Now here we have taken the normal hexane, okay, and added H2SO4, okay, and SO3 is also taken with the temperature 675 Kelvin. Okay, so this temperature should be nearby this only. Okay, and naturally here we will be seeing what? Here hydrogen will be replaced by the sulfonic acid group, that is HSO3, okay, thereby forming normal hexane sulfonic acid, and yes, water also will be released out. So oxidation reaction, okay, here oxidation reaction takes place through combustion, okay, control oxidation, catalytic oxidation, okay, combustion reaction. Okay, when we are talking about this, it is of two types: complete combustion and incomplete combustion. Okay, when there will be surplus amount of oxygen, complete combustion or complete oxidation will take place. Okay, and yes, where the oxygen is provided less, it will be incomplete combustion or incomplete oxidation also, you can say. Okay, so if we are taking methane, okay, and adding oxygen in a surplus amount, we get carbon dioxide and we get water, okay, and yes, plus heat will be evolved, okay, and yes, if we are taking butane, okay, and it is burned, okay, or it is heated with what? Oxygen, that is 13/2, okay, you can write 6.5, okay, or 13/2, and naturally you are getting what? Carbon dioxide, which is in more amount than if we have seen with methane, okay, and yes, water is also released and plus heat is released. Okay, so if we talk about the general equation, okay, of this combustion reaction, okay, alkane, we can write CnH2n plus 2, this is the formula of a saturated hydrocarbon, okay, plus 3n plus 1/2, okay, bracket close, O2, plus this much, it is the amount of oxygen required, how much you are taking, you will be calculating it with the formula in the bracket 3n plus 1/2, okay, it will be giving the number you have taken, that is N CO2, anything it can be, okay, plus in the bracket N plus 1 H2O, and plus heat will be evolved. Okay. So here we are saying basically in complete combustion that carbon dioxide is released out. But what happens in case of incomplete combustion? Okay, here limited supply of oxygen is there or limited supply of air is there. Naturally what will happen, there will be unburnt carbon or carbon black will be formed. It means what? Total will be not converting into carbon dioxide. Okay, so complete combustion is not taking place. So instead of carbon dioxide, what will be formed? Carbon monoxide. Okay, so if we are taking methane and we are taking oxygen, naturally you are seeing this oxygen is not in a surplus amount with that's methane, the molecules it has been taken. So we are getting what? Carbon monoxide plus water. Okay, so here we are seeing that instead of getting carbon dioxide, we are getting carbon monoxide. If more, okay, this carbon monoxide is also converted into carbon, and that also is an incomplete combustion or oxidation. So catalytic oxidation and controlled oxidation, what happens in this? Okay, we will be adding some reagents to it, okay, and then the reaction will be moving on. Okay, so here we are seeing that yes, we have taken what? Methane. Oxygen is being added in the presence of copper, okay, and the temperature is 573 Kelvin and pressure is also there. So you should mind it that yes, in catalytic oxidation, temperature, pressure as well as the reagent, okay, works. Okay, so here what will happen in the presence of this copper and 573 Kelvin and 100 atmospheric pressure, we will be seeing that here methane will combine with oxygen to form what? Methanol or methyl alcohol. Okay, now again methane taken, okay, plus oxygen, here also this same thing, okay, but here the reagent taken is molybdenum oxide, okay, and here we are heating in and applying pressure also over here, and here we are seeing what? We are getting an aldehyde, that is the methanol plus water, okay. Now if we are taking any alkane, okay, and we are adding, okay, what? Oxygen, and we are using oxygen, that you can see the molecules also, you have to take it in mind here, okay. So here 3O2 is taken, okay, and the reagent used is silver oxide. We are heating it, and here we are getting what? An acid, okay, an acid we are getting over here, plus water is released out. So you can see basically everywhere alkane is used, but when we are using the reagent, different reagent, we are getting alcohol, aldehyde, okay, and here we have got an acid, okay. So this here it is combining with oxygen, okay, in the presence of some reagent, okay. So this type of reactions are known as what? Catalytic oxidation or controlled oxidation, okay. So in this case we are seeing that yes, when we add this alkaline KMNO4 or K2Cr2O7, okay, it means potassium dichromate or this potassium permanganate, okay, here they don't actually work, but yes, they work in some cases, okay. Like if we have taken what, in this we can see it is 2-methyl propane, we have here this reagent provides what? Oxygen, and that is the nascent oxygen, thereby turning it to what you can see here, it is what? Tertiary butyl alcohol, isn't it? So here tertiary butyl alcohol is formed from what? 2-methyl propane, okay. So here this alcoholic KMNO4 is acting over here, and yes, potassium dichromate also acts in some reactions, but basically they don't have much effect on this alkanes. Now coming to the next chemical property of alkanes, isomerization, okay. Here we can see that yes, normal butane has been taken, and yes, what we are providing? Aluminum chloride, AlCl3, okay, and hydrogen chloride or hydrochloric acid, okay, and here temperature has been provided 573 Kelvin. So temperature, whenever you write around this only, okay, and yes, 35 atmospheric pressure is also provided to this, okay. So what happens? What do we see? That we see that here this normal butane has been converted into isobutane, or we can say normal butane isomerized to isobutane, okay. So we can see here that yes, if we are adding the reagent aluminum chloride and hydrochloric acid with temperature 573 Kelvin and 35 atmospheric pressure, this normal butane gets isomerized to what? Isobutane. So here isomers of this normal butane has been formed. Thus isomerization takes place in case of alkanes if we provide the reagent, okay, and the temperature as well as the pressure, okay. Next is the aromatization. What is this aromatization? Here you can see single bonds are there, okay. So here 6, 7, 8 carbon atoms, okay, consisting of carbon atom chain, 6, 7, 8 carbon atom chain. Adding the reagent like chromium oxide or vanadium pentaoxide, okay, And yes, the temperature 773 Kelvin, you can also write around it, okay, and 10 to 20 atmospheric pressure. What happens over here? Okay, we can see this, we have taken 1, 2, 3, 4, 5, 6. So cyclohexane has been formed, and yes, this hydrogen has been removed out, one molecule of hydrogen. Yes, afterwards we see that yes, the reaction goes on, and yes, dehydrogenation takes place, thereby forming a benzene ring. And here you can see that yes, 3 molecules of hydrogen has been removed out. Okay, thereby this being forming what? Benzene. So we have taken just a linear chain. Okay, cycling form has been formed in between, and yes, at the end we get a aromatic ring, and that is of benzene. Okay, now when this alkanes are reacted with steam, then what happens? Okay, like here we can see methane, when it is reacting with water, okay, and yes, nickel is present, okay, and here nickel acts as a catalyst, heat is provided, we get what? Carbon monoxide and hydrogen. Okay, so in case of pyrolysis, what happens? The higher alkanes, okay, providing temperature, okay, 773 Kelvin, okay, it means a high temperature is provided to it, okay, it gets break up into or cracks into a mixture of alkanes and alkenes. Okay, this pyrolysis is also known as cracking, because here a bigger alkane will be breaking up, okay, or it will be forming with the temperature provided the different alkanes and alkenes, like C6H14, okay, this is normal hexane, okay, providing the temperature 773 Kelvin, you can write around 773 Kelvin also the temperature, okay, okay, and then we are getting what? C6H12, that is hexene, okay, and hydrogen, as well as we get C4H8, okay, this is what? Butene, and plus C2H6 we are getting, okay, this is what? Ethane, and here we can see that it is also formed C3H6, that is propene, okay, C2H4, that is butene, okay, and methane we get. So here we see from this normal hexane we have a mixture of alkane and alkynes, and yes, in this process pyrolysis, cracking of the alkane is being done, thus it is also known as what? Cracking of alkanes. So hope students you might have understood about the chemical properties of alkanes. Good day, take care.